Well, here we are at Belcarro apartment building in Bellevue, Washington. I'm joined by Andy Teasel, who's the project engineer for the Canadian division of iLevel by Weyerhaeuser. Andy, obviously we're in this quite large unit, and I think it's a good display of the iLevel products in here. If you'd like to take us through some of the system that you can see.
Sure. Thanks for having me here, Steve. This is the floor systems in this project are supplied by iLevel by Weyerhaeuser. They're an I-joist system and engineered wood products throughout. And what they're doing is they're taking advantage of some of the great features that you can do with this kind of product. For example, if you're looking up in the upper levels, there are a number of mechanical and electrical services running through the system. With that, you have the ability to keep that mechanical work up in the ceiling space rather than, if you think about alternatives, an architect may be required to drop those services, create a bulkhead and an unsightly architectural feature.
I see they've punched through with the sprinkler lines are obviously mandatory in this type of building. There's obviously rules governing the hole size and location inside the joists.
Yeah, there are. Generally speaking, the further away from a support, the larger your hole that you can provide into these products. The key is to keep them inside what we call the web, not the flange material in the top and the bottom. And if you do that, you can get 4 or 5 inch holes through these kinds of products easily. The other thing that's nice about them is some of the services are running along the same direction as the joists, and as opposed to some systems, you don't need a bridging element with this product line, so that you can run systems and have them unobstructed.
Now, this is obviously quite a wide unit from bearing to bearing. Can you sort of explain a little bit about why they've doubled up the I-joists?
Yeah, they had some choices as a designer. They could have tightened up the spacing, but what that results in is limited access to the joist space itself for services such as plumbing. But the primary reason is as well, not only for the spacing, but this is a large room. It's 21 feet, so they need extra framing material to achieve the code requirements there.
Okay. And I noticed on the shear walls there, to keep the continuity of the shear wall, they've actually clipped in blocking panels for the load transference.
Yeah, this is a good place to stop and talk about that, Steve, because the particular products used at that blocking location have some very special properties when it comes to shrinkage as well. Okay. When you're talking about putting 4, 5, 6 stories together, managing shrinkage is a huge part of the design challenge. And some of these engineered wood products, like the one we're looking at here, Timber Strand, has incredible shrinkage properties. It's very, very stable and can lead to better performance for the overall building. So not only is it important seismically, but it's going to lead to a much more stable and dimensionally stable building. So another engineered wood product worth highlighting here, Steve, is the floor system that we're standing on. Engineers in this market have a preference for this type of panel, edge gold, for a couple of reasons. First of all, it's reliable. Generally speaking, engineers like reliable results out of their designs. This product delivers that. It has Douglas fir nailing values so that their diaphragm capacities are as high as they can be per code. And what's really outstanding about something like this is in a wet weather environment, it's clearly stood up well. It has the dimensional stability to get things done right through the project. So.
And it's one of the products that's rated for a 24-inch on-center joist spacing?
Yeah, it's held up. It meets code requirements for that. And so for 24-inch on-center joist systems, this is the panel to choose.
Okay, great.
There's a couple of things in the next room that we can talk about.
Okay.
So here's this example I was talking to you about, Steve. We're beside the typical window in the building. And most of it looks normal, except you notice there's a lot more framing here, and there's a couple of reasons for that. The first one, of course, is that there's a lot of vertical load coming through this part of the building, and it has to be dealt with. Right. But the other part is, and something to think about in any wall design today, is this is a wide window, and it's well exposed high up, and it's being exposed to wind loads. Wide, tall windows require a little more attention. So what we've got here are some extra connections, a number of additional members that take care of not only the vertical, but make sure that in terms of the wind pressure on this wall system that it's being dealt with. And that leads up not only from this point, but right up into the ceiling level. Well, you'll notice that this is a detail you'll see often in multifamily construction, certainly of this size, where there's some blocking that's running perpendicular to the joists. That blocking serves a couple of purposes. It's there for seismic reasons. It's also preventing a hinge from being formed where the wall meets the ceiling level and keeps things vertical and stable during the construction phase.
So along with the sheeting, it's also keeping the floor system rigid with the rim board, so everything's sort of acting as one system.
Absolutely. It's tying it all together, and that's it's critical. It's absolutely critical in a building of this size.
Right. Well, Andy, this is a fabulous unit. It kind of brings together everything we've been talking about, product-wise anyway. It's a great illustration of really everything.
Yeah, it really is. We've got examples of engineered wood products throughout this penthouse unit, starting with this wall in front of us, which is about 18 or 19 feet high. They've elected to use a lumber solution for it, and that's quite surprising for some markets, because it's difficult to find lumber of that length in most parts of the country. A solution in other areas may be an engineered wood product, just simply to achieve the heights that you need with something like that.
There's also a really good interesting example of parallel cord trusses here. They've been fabricated with a slight taper because above them is actually the flat roof of this building. Obviously we're in a loft area as well, but this forms the deck for the flat roof, and the tapering is for drainage, obviously, all being supported by a PSL beam.
Yeah, it's pretty impressive.
What's really, I think, gives this unit its charm is actually this big roof system above us here. So if you want to take us through maybe some of the design aspects of it.
Yeah, what a nice space. I'm impressed. It's really nice. One of the things that makes it good is you've got a flat roof up there, very high up, and they're taking advantage of TGI joists, which oftentimes people think of them just for floor systems. But here we have two examples. We've got a roof truss system over here where you need it for a sloped application, and for a flat roof we have I-joists, which can work very, very well. I find it quite interesting, the detailing. It's a double cantilevered overhang, which does create a number of design challenges for the structural designer. But they've taken advantage of engineered wood here with a diagonal parallelogram beam to go right out to the corner and pick up the loads as required.
Yeah. It forms quite a great canopy on the outside.
Yeah, it's very nice.
Also leads to some challenges for fire rating. I'm sure there must be something that's applied on the underside of that soffit. What's interesting as well is we see the continuation of the sprinkler system within the units, how they've punched out, and there's a sprinkler on the other side which I think is a sprinkler of the balcony. Very interesting.
All in the name of fire protection, and yeah, it's a great unit. We talked earlier on about the importance of wall design. This room really does highlight that as well, just how important it is to manage wind loads as well as vertical loads in a building like this.
Right. If you want to head outside, we can just take a look at the building that was the first one built in this project. And actually you can see how they've dealt with the fire issues on the soffit line there that's been created by the roof system. They've actually put a fireboard up underneath the side of the joists there.
Yeah, just purely to prevent fire exposure.
Yeah. And it gives us a chance actually to look at the cladding materials that they've used on the outside of the building. They've got the rain screen, obviously, some strapping, and a cementitious board that forms the lap siding. And I'm assuming that is a preparation for a stucco finish on the outside.
So basically all of it non-combustible.
Exactly.
While the design of BC's 6-story wood frame buildings should not be taken lightly, it certainly is doable. As our neighbors to the south have experienced, the main items of concern are shrinkage and hold-down systems and the use of engineered wood products, pre-planning and scheduling of construction materials to and from the site, and the need for extensive construction details from the integrated design team. There's no doubt that mid-rise construction will be a new market segment for many suppliers, manufacturers, and designers, opening the door for leading-edge products and services. With an experienced design team, the end product will be high quality, cost competitive, and more environmentally friendly than that of traditional high-rise buildings. 6-story wood framing in BC. It's all in the details.